Welcome to Blue Angel Robotics. My name is Emma, and today I'm going to teach you how to follow a line smoothly with the color sensor.
First, drag and drop a loop block to the programming canvas. Then get a color sensor block. Click Measure, and then select Reflected Light Intensity. The RLI value can tell us how close the robot is to the line. When the color sensor is getting close to the black line, the RLI value gradually decreases. You can use the RLI value to help the robot follow a line. Next, you need to decide whether you want the robot to follow the right edge of the line or the left edge of the line. To follow the right edge of the line, the robot needs to turn left when it's on the white area, and turn right when it's on the black line. Before we go back to the programming part, there are two RLI values you need to measure. First, the RLI value of your white area. Second, the RLI value in middle of your black line. If you don't know how to measure RLI values, you can watch my earlier video, 1.8, How to Measure Reflected Light Intensity, RLI, with the color sensor. Let's now go back to the programming. Go to Data Operations tab, drag and drop a math block. Click Add, and then select Advanced. Input the RLI value of your white areas to value A. Mine is 78. Yours might be higher or lower. Next, send the RLI value to value B by connecting the color sensor output to value B. Let's input 1 for value C for now. I will explain why we need value C later. Now let's do some math. Go to the equation box, input A minus B times C. Then, let's send the result to a variable for a later usage. Go to the Data Operation tab and get a variable block. Let's give this variable a name. Click Variable Name, then select Add Variable. Type in B power as the variable name. The default mode here is Write Numeric, which is perfect for this task. Now let's connect the math output to the variable input. A variable is a location in the memory of an EV3 brick that can store a data value. The reason we named this variable B power is because we want to pass this value to B motor as the power. Let's imagine what will happen here. If we are in white area, the B value will be about 78. Then the power value will be 0. So if we pass this value to the B motor will not move at all. When the robot getting closer to the black line, the B value decreases gradually. As a result, the power we pass to the B motor increases gradually. The RLI value in middle of my black line is 8. That means the maximum power the B motor can get is 78 minus 8 times 1 equals 70. And it happens when the color sensor is in the middle of the black line. Then let's see how we want the C motor to move. Drag and drop another math block. Click Add, and then select Advanced. Send the RLI value to value A by connecting the color sensor output to value A. Input the RLI value in middle of your block line to value B. Mine is 8. Let's input 1 for value C. Now let's do some math again. Go to the equation box and input A minus B times C. Let's get another variable block and name it as C power, and then connect the math output to the variable input. Later on, we'll pass C power value to C motor. Let's imagine what will happen here. If we are in white area, B motor will barely move, and C motor gets maximum power, which is 70. As a result, the robot makes a left turn to find more block. When the robot is in the middle of the block line, the C value will be 8 minus 8 times 1 equals 0. That means the C motor stops moving, and at the same time the B power is at the maximum. As a result, the robot turns right to find more white. In theory, when the power passed to B motor is equal as C motor, the robot won't make turns anymore and go straight. That's going to happen when the RLI value was 43, so that both equations get the same results, equal with 35. Let's now pass the power to motors and see how it works. Drag and drop another 2 variable blocks. Click Read, and then click Numeric. Let them read the value from B power and C power variables, and then pass the value to B motor and C motor. Now run the program and see what happens. Yes, you can see the robot follow the line, but it's jaggy. Why? Because the power passed to the motor is too strong. Go back to the program, change both of the C value to 0.4. That means we now pass less than half of the power comparing with the previous version. Let's see how it looks now. It's not jaggy anymore. You may want to follow a color line instead of a black line. Remember, the only difference is the RLI value between a black line and a color line. Once getting the RLI value of your color line, you can replace the black line RLI value in this program to make it work. If you need to follow a color line and the color line has similar RLI value as white, it becomes tricky. For example, the red line. You may find your robot barely moves in this program. In this case, you need to increase the C value to increase the power pass to motor.
Thanks for watching. Click the like button and subscribe to our channel if you like the robotics videos. And if you have any suggestions, please leave a comment below. Thanks!